Over the next few minutes, I'm going to take you through how Tindo Solar manufactures a module. The machine behind me is a machine called a tabber stringer. Its job is very critical to the longevity and the performance of a solar module. So it has to take a cell like this, a high quality cell, which at this point doesn't have any ribbon on it. So we need to solder ribbon onto the top and the bottom. And that will carry electrons, which is then the main function of a solar module. So the machine will pick up the cell under vacuum, take it and put a special flux where the ribbon needs to go, then onto a preheat table so the cell is not shocked. Then the ribbon goes on and hot air guns come down at about 400 degrees C for 1.3 seconds. So the whole process takes around 2 seconds to solder each cell, and we need 6 lots of 10, and then that gives us the full 60 cell complement, which makes up the Tindo panel. So once we have our tabber string finished its job, the next section is to take those lovely strings, all nicely, beautifully soldered, and to take them onto the layup table. So the layup table will take the full 60 cells in 6 rows of 10, but it needs to be exactly accurate. That way the panel is completely formed and the current can flow quite easily and naturally across all 60 cells, again underpinning performance and output. We have the next machine pick all that up together, and then we start the auto soldering section. We solder that full 60 cells into a complete circuit. So after our panel is now soldered into that complete circuit, the next challenge is to get it to the point where we have a fully formed solar module. So we need a layer of glass, high quality glass, then the encapsulating material, which is called EVA. We need 2 layers of that, which sandwich the wafers or the cells. So it goes glass, EVA, cells on top, EVA, and then the back sheet. So here we have it here. We can see the fully formed module. We have a back sheet, it's a high quality back sheet. Then we have our encapsulating material, which is known as EVA. And we have 2 layers of that which sandwich the cells. And here are the cells all nicely soldered. There's our second layer of EVA, and then there's our glass. And you can really cut corners on any element in here. You can have a cheaper backsheet. For example, this is our Tindo backsheet. This is a genuine high quality backsheet. Very important, a solar module is a high voltage, high current appliance. And you cut corners anywhere at your peril because there's high voltage in this stuff. This stuff can actually kill you, and it has been known to burn houses down. But it's cheaper if you go cheaper backsheet, cheaper EVA. We don't in Tindo. The other part of the element is to make sure that there are no hairline cracks in a solar module. So this is about a $100,000 machine out of Germany, a company called Bohm, that will look for a hairline crack. And you can see over here, its role is to check every single cell in that panel, all 60 of them, looking principally for hairline cracks and any damage. So by putting every panel through this process, we can guarantee that panels come out of this factory without a hairline crack. So there are many factories in the world which won't even have this box and won't have this check. We do here at Tindo. At this point, a hairline crack can be identified. If need be, we can take that cell out and replace it, recheck it, and then we know it comes out of this factory without a hairline crack. And so the question is, well, what's the importance about a hairline crack? Particularly in DC systems where you have panels grouped into 3, 4 or 5 quite often, whatever happens to one is replicated across everything else. So if you have a hairline crack and you're losing 1/3 of one panel of its performance, you're actually losing 1/3 of everything connected to it, which becomes quite a serious reduction in your performance for life. So we can take that out in this factory and guarantee everything comes through without a hairline crack. That's quality. We then need to seal that panel to make sure it will genuinely last, in particular the harsh Australian environment. So that's the function of these laminators. These are very large, 18 tonnes a piece. We have 2 of them, 4 panels at a time. It's about 17 or 18 minutes it sits in there in that process, which is under vacuum and temperature. When they come out, they're like this, where we have them sealed for life. And they need to be. The Australian environment's a pretty harsh environment. Temperature changes, high, cold, wet, etc. In fact, we will warranty these panels completely flat. One of the few companies in the world that will ever do that. From here, we need to visually inspect it. And that means then that we have an operator that will physically explore every single inch of this panel, check that the tolerance is all fine, and there's no mistakes in here. Very rare for that to happen at this point, but still we will check it. And everything is all bar-coded. So there is full traceability of every single element in the panel through the whole factory. Once the barcode's on, we simply need to trim off the edge here, the surplus material. So we have a very clever machine which is called an auto trimmer. It will simply run around with a very hot knife, very sharp, and trim off that edge. Then it's ready for framing. In framing, a very important step to the longevity of a panel is the materials that we use in the frame. We elect to use the only product known to man that has never failed, and that is Dow Corning silicon. It's the only product that actually has been in a panel for 30 years out in the real world. Once the panel is framed, we then go for junction box application, which again is with silicon. We use a high quality German junction box, not a plastic one. We then go for either the microinverter put on, which makes it an AC factory fitted panel, or a DC panel where the microinverter is not on. The last step is the flash test, which validates what the panel is actually going to do in real daylight. And that again is barcoded with the panel, so again we've got a full reference, panel, materials, how it was made, when it was made, who the operator was, what the label of the junction box is, as well as the microinverter, and then we're set to go out to you.